Welcome to Knowledge Share channel. In this video, we will be discussing about some problems related with electric drives. As you all know, problems play a very vital role in engineering syllabus, and drives nowadays has taken a very important role in EV designs, and because of which we should be aware of solving the problems in electric drives. So, here in this video I have planned to give you an overview of different types of problem. What are the two major classification of the problems in drives as well, and I will be solving two different problems. This is what all about in this video, and let us go into the topic today. So, here the basic formulas, okay, in any electric drives the basic formula is given by this is the most important formula, okay. This is the most important formula, please remember it. I don't know, it is the most important formula, okay. This one, okay. This one is the most important formula. Why I am saying is, if you remember this, you can solve many different types of problem, okay. So, it is very simple, N2 by N1, okay. N2 is nothing but speed, okay, the speed at some RPM. N1 is nothing but the speed at initial RPM, N2 is nothing but the speed at the desired RPM or something like that, will be equal to EB2 by EB1, okay. So, N2 by N1 equal to EB2 by EB1 into phi 1 by phi 2. So, this is a very important formula in drives, okay. And how to find this EB2 and EB1, okay. So, EB2 and EB1 can be found out by using these two formulas, okay. This one can be found out by using these formulas, okay. So, EB1 is given by V1 minus IA1 R1, okay. As you all know from the motor dynamics, the voltage supplied will be equal to, so here we will be solving for motor, okay. So, this is a motor. So, the terminal voltage will be equal to back EMF plus the armature voltage drop. So, if you just interchange it, so you will be getting the back EMF as EB1 equal to V1 minus IA1 RA, okay, because RA remains constant. So, IA1 is the one which is going to change with respect to change in torque. So, this is the term which is going to change, IA1 is going to change with respect to change in torque. So, similarly, what is EB2? So, EB2 is nothing but again V2. So, most of the time this V1 and V2 will be equal most of the time, okay. That is, this will be the terminal voltage, so it should be constant, okay. So, if sometimes if they change it, you have to make a note of it, but most of the time it remains same, okay. So, this V1 V2 will be equal to, so here EB2 will be equal to V2 minus IA2 into RA. So, again you can see that two different IAs are there, okay. Armature current, what is this? IA is nothing but armature current, and V is nothing but the terminal voltage, EB is nothing but the back EMF, and phi is nothing but the flux. So, hope you all remember all those things, okay. So, you need to understand the basics, okay. If you are not clear with the basics, you can just watch the previous videos and come back, okay. So, this is the main formula by which you can solve the solid state drives problem. So, please make a note of it, okay. So, okay. So, now any electric drive problem is classified into two types. One is constant torque problem, the other one is the constant flux problem. What is it constant torque? So, here you can see in constant, this is one, that is one is constant torque, the other one is the constant flux, okay. So, any electric drive problem will be classified into two types, one is the constant torque, the other one is the constant flux. In constant torque problem, you can see that the torque remains constant. So, here you can see that, see, so since the torque remains constant, TA1 equal to TA2. So, it is very, very important. So, this has to be taken. So, if TA1 equal to TA1, as you know that the torque is always directly proportional to phi into IA. Is it right? So, this is a very important thing which you know, is it right? And so, because of which you can see that TA1 will be directly proportional to IA1 into that is phi 1 into IA1, and similarly TA2 will be directly proportional to phi 2 into IA2. So, from which we can conclude here, okay, from which we can write directly as, so since TA1 and TA2 are constant in this problem, so phi 1 into IA1 will be equal to phi 2 into IA2. Is it right? So, it is very simple. So, by using this condition, what we can do is, in this, sometimes they will be giving the value of phi 1, they will be giving you the value of I A 1, and you want to find what is phi 2 and I A 2, or they want to find phi 2 also will be given, and you want to find what is I A 2. I A 2 will be unknown, and after finding I A 2, you want to substitute that particular I A 2 in the equation which we have already discussed, okay, in the previous slide, and in that equation you just substitute I A 2 and you can find what is the actual speed, okay, right. So, similarly, in constant flux method, so this is the basic formula, N2 by N1 equal to EB2 by EB1 into phi 1 by phi 2. So, this is the basic formula. Since in constant flux, since the flux is constant, you can assume that phi 1 equal to phi 2, is it right? So, phi 1 equal to phi 2. So, since phi 1 equal to phi 2, the equation is simplified is that is N2 by N1 will be equal to EB2 by EB1. It is very simple. So, you can find EB2, you can find EB1 using the previous formula which we have discussed, and you can just substitute here and you can calculate it. So, this is how we want to proceed. Okay. So, this is the basic way how to solve this problem. So, now we will move on and we will solve two different types of problem, one in constant torque method, the other one is the constant flux method, okay, and you will get a better understanding. So, now you can see this is a basic problem. This has been asked in many of the GATE question papers as well in many of the university question papers. So, the question given is a 250 volt, okay, it is a shunt motor, it is a DC shunt motor. So, you can see that a 250 volt, okay, a 250 volt DC shunt motor, it is having an armature resistance, that is RA is given, okay, RA is given as 0.5 ohms and runs at 1500 RPM. So, what is it? This is nothing but your N1. So, it is already running. So, you are giving 250 volt as input and armature resistance is 0.5 ohms and it is running at 1200 RPM. Now, for example, when the armature current is 80 amps and also the armature current also the value is given is 80 amps. If the torque remains constant, see it is given unchanged, unchanged means it is constant, okay, the constant, there is torque remains constant, this is the condition which has been given. So, now your problem falls under the first type, okay. So you want to find what is the speed, okay, and you want to find what is the armature current when the field is strengthened by 25%. So, you can understand the problem first. So, these are all the given data. So, you can see that in given data V1 is given as 250 volt, N1 is given as 1200 RPM and phi 2 is given as, since the flux is strengthened by 25%, it should be phi 2 will be equal to 1.25 into phi 1 and armature resistance is given as 0.5 ohm and armature current is given as 80 amps. So, these are all the given data. So, now as we have already discussed, this is the basic formula which we have already discussed in the previous slide, that is N2 by N1 will be equal to EB2 by EB1 into phi 1 by phi 2. And here it is a constant torque problem. So, this is the condition which we have to remember, okay. So, that is it will be TA1 equal to TA2. So, phi 1 into, so TA1 will be equal to phi 1 by, as you know that phi 1 by IA1. So, since torque is directly proportional to phi into IA, okay. So, this is the base. So, then TA or TA or whatever, that is armature torque or something like that, okay. So, TA1 will be equal to TA2. So, here phi 1 into IA1 will be equal to phi 2 into IA2. So, it is very simple. So, this condition has been given. So, you just substitute here. So, what are the data that has been, so you have given with what is phi 1, you know what is phi 2 and you know what is IA1. IA1 is given as 80 amps. So, now the only unknown is IA2, is it right? So, now the only unknown is IA2. So, from the next you can see that I will reshuffle this equation and this equation is written like something like this, okay. So, IA2 by IA1, that is 80 amps will be equal to phi 1 divided by 1.25 into phi 1, because phi 2 will be equal to 1.25 into phi 1. So, now you just calculate and finally you will be getting the value of IA2 will be equal to 64 amps, okay. So, now you just want to find, see this is the you know that the basic formula is, what is the basic formula? So, N2 by N1 equal to EB2 by, so that basic formula already we have discussed, that is N2 by N1, yeah. So, you can find as EB2 by EB1, is it right? And EB2 by EB1 into phi 1 by phi 2, already we have discussed. So, the same formula. So, here you can say write the same formula. So, the N1 is already given, okay. So, N1 is given as 1200 RPM and EB2 you want to find. So, this is already the EB2 current you have find IA2 as 64 amps, whereas IA1 is already given as 80 amps. So, now you have calculated EB1 as 210 volt and EB2 as 218 volts. So, you just substitute here, okay, and phi 1 is given as phi 1 is, you can see that, and phi 2 is 1.25 into phi 1. So, these phi 1 and phi 2 will get cancelled, both phi 1 will get cancelled. So, the only unknown is N2, okay, the only unknown is N2. So, N2 is the only unknown, okay. So, it is very simple to calculate. So, this is the only unknown in this equation, this is the only unknown, okay, whereas remaining nothing is there. So, directly you can substitute and I will be getting the answer as 997 RPM. So, this is how we want to solve the electric drives problem, okay. So, this is one type of problem where torque is given as constant. So, now we will move on with the next type of problem in which the flux will be constant. Okay. So, here the torque is constant, in next problem the flux will be constant. So, we will move on to the next slide. So, here you can see that, so this is one more type of problem. So, here in this problem you can see that here 500 volt DC shunt motor, armature and field resistance. So, here both armature and field resistance are given. So, if this is given, your armature you have to calculate in a different way. Armature resistance is 1.5 ohm, and whereas field resistance is 400 ohms. Okay. So, this is your RA, okay, and okay. So, this is your RF or RSH, that is shunt field resistance, so RSH. Okay. So, it has been given. So, you have done, and when running a no load current. So, this is the no load current of 5 amps and the speed is given as 1000 RPM is given. Okay. Calculate the speed when the motor is fully loaded and the total current drawn from the supply is 30 amps. Okay. So, now you can see that it is a shunt motor, okay, and there is no mention of flux, is it right? So, there is no mention of flux. So, we can assume that the flux remains constant. Okay. If there is no mention of flux, or sometimes if they also mention, okay, then you have to assume, you have to find out something like that. Other, if it is not mentioned, you have to take it as phi 1 equal to phi 2. So, this is the basic formula as we have already discussed. N2 by N1 will be equal to EB2 by EB1 into phi 1 by phi 2. So, you write the given data. So, the terminal voltage is 500 volts, armature resistance is given as 1.5 ohms, and similarly shunt field resistance is 400 ohms, and I naught is, there is a no load current is 5 amps, and similarly the load current is 30 amps. And you also have to remember the formula, that is the load current. Okay, always you can see that. Okay, the load current will be in case of any armature or any motor, load current will be equal to IA plus ISH, is it right? IA plus ISH, is it right? So, this is the basic formula for any motor. So, from this you want to calculate, okay. So, from this you want to calculate what is IA, because only this is given, okay, IL is given, okay. So, now you want to calculate what is IA, and ISH can be calculated by how to calculate ISH is V by RSH, okay. So, IL is given, okay. So, you want to calculate only IA. So, by calculating IA, then you can substitute it in the EB2 and EB1, and you can find what is the value of speed at N1 or N2 or something like that. Okay. So, now please remember this formula. Okay. Now, we will move on with how to solve this problem. So, here you can see that first you want to find, as I have told that the shunt field current has to be find. So, you can see that shunt field current is nothing but terminal voltage divided by the shunt field resistance. So, your answer is 1.25 amps. So, after finding it, so this is the basic formula, that is the load current. So, this is no load current. So, I have taken as I naught or IL naught, we can say. So, since you know that is the load current, okay, will be equal to, this is the basic formula, IA plus ISH. So, from this we can derive it, okay. From this you can see that I want to find IA. So, IA will be equal to IL minus ISH. So, IL here which is I naught because it is no load current. So, no load current is given as 5 amps and 1.25 amps is the shunt field current which we have found out. So, finally, we have calculated what is the no load armature current is 3.75 amps. Now, you have to calculate what is EB1. So, EB1 formula it is same. So, V minus IA naught into RA. So, you can substitute. So, V is nothing but 500 volts is given and 3.75 amps is the IA naught and RA resistance is this. So, you just find and EB1 has been calculated. So, finally, we are going to substitute here in this formula. Okay, we are going to find, so now you have found out EB1. Okay, now you want to find EB2, and since the flux is constant, so these two will get cancelled. Okay, and finally this will be changed to this. So, N2 by N1 will be EB2 by EB1. So, now EB1 has been calculated, the only unknown is. So, now you want to calculate what is that is N2 is the only unknown. You want to calculate what is N2, and N1 is already given. Okay, it is 1000 RPM. Okay, it is given as 1000 RPM. You have just substituted here EB2 by EB1. So, similarly, what is IL? So, IL is given as, that is the load current is given as 30 amps. So, just substitute 30 minus 1.25, it will be 28.75, and you substitute, you find, so here, okay, so here I am going to substitute this IA2, 28.75 has been substituted, the terminal voltage remains same, and finally I have got this answer. So, this is the answer for EB2. So, EB2, the answer is 456.875 is the answer for EB2. So, now you just substitute here, okay, that is 456.875 has been substituted here for EB2, and similarly 494.375 for EB1, and you calculate what is N2, only unknown is N2. So, you have calculated what is N2, so the formula for N2 has been, so you just rearrange this equation, and the final magnitude will be for N2, that is the speed at what speed now it is running for a different value of armature current, okay, for different value of load current. Okay. So, initially when it is running at no load condition, it was in 1000 RPM, and when it is loaded, it is running at 924 RPM. So, this is what the final findings. Okay. So, as you load the shunt motor, the RPM gets reduced. So, these type of problems you may expect in many of the GATE question papers. I am sure this video has been given an insight of how to solve various types of drives based problem, and thank you very much for this, and if you really like this video, give a thumbs up to this, and as well, if you have any doubts, you can just comment in the box, and if you really feel that if this particular video will be useful sometime, you can just share to them, and you can just subscribe to my channel to have a note of the future videos, and hope this video was very useful to you. Thank you.